best way to test something.
Well, it's the best way to test, but it doesn't really explain, whether something should be done like that or not. Okay, okay, I need to pound into that. Okay, it's fine.
Let's see if it crashes.
I don't think it will crash. I really don't think so. There you go. Still wasting 1 second. You can read it back too. I'll bet you we can read it back later on. Well, if you read it back, you have to read it back almost immediately before we perform any type of system calls, because any system call will change it to
The pthread
another
functions
value.
don't use error now.
Huh?
The pthread functions don't use error now.
Do they?
They don't.
They do not. They return the error number right away.
Yeah.
So, but printf does. But printf is in a child process, so it should not affect the main one. Okay, so that's good. So we'll just go ahead and print here. Okay, we'll make it a little easier to read. Yep, still 5.
And all those X's.
Yeah, because all the X's that's coming after it. Why would that be after?
Because it doesn't die immediately. It's maybe
So the call
fast.
returns before it actually gets it killed.
Yeah,
Oh, because we have
and
a
it's
manager
flushing.
thread.
It's flushing on exit as well.
But they have the same file handle. I think it has to do with the manager thread, which is the only one responsible to kill a thread, is taking its time to kill the child thread.
Well, it's taking its
But they
cycles.
have joined already. By the time you return from join, they should have
You
joined
didn't
already.
join. You had join commented out.
Hmm?
Didn't join.
I did?
No.
That's why. So the two are now out of sync. Okay.
Mhm.
This is also a good test to see whether the join actually should be doing what it's supposed to. In other words, we put the join back after the sleep.
That's just gonna wait forever.
Oh, because
Because your function never.
because it never dies. Yeah. Yes. Make. I
Hack
really
needs a
should
make file.
There you go.
200 X's. Wow.
Yep. So any questions at this point? I mean, that really confirms, the use of join. If you use a join operation, join does not return until the two threads become one. Yep.
Can we stick some sleeps in there and some printfs in the main function and really see that XY interleave?
It'll interleave. I mean, if you sleep, 1 second each, it'll go like ding 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 like that.
Yeah.
Yeah.
That'd be fun. Let's do that.
Christmas lights. Okay, so any questions about this particular slide, which is really kind of trivial because all it does is to create a child thread and wait for the two threads to join again. Yep.
Could we say use pthreads to create a bidirectional data pump?
Someone has been reading ahead. Turn off your read ahead cache, man. Turn it off. Okay, now that's exactly what we're gonna do next. Okay, now have we encountered something like this, a bidirectional data pump?
Yes, and it was painful.
Well, it's our homework assignment. Okay, everything from socket 2 and up, up to socket 4, they are all, each client is a bidirectional data pump, and so is the server. The server is also a data pump. It is bidirectional because it has to get something in and then echo everything back out again. Yep.
If you're writing to having multiple input streams writing to the same output stream, you could have collaborating your output. You should be using mutices to isolate writes.
Say it again?
You should be using a mutex to isolate your writes.
because the writes can be writing to the same. I'm assuming they are different file descriptors.
Yeah.
Eventually map to different streams. Without that assumption, yes. Without the assumption, you have to use mutex. So anyway, but just to illustrate the concept, if we are to write a program to pump data in a bidirectional way, it can be done with non-blocking read and write methods, which basically is a busy polling type of method. Do I have anything to read? Do I have anything to read? Do I have anything to read? And you just keep asking the question until you have something to read. And then you try to write to the output part, and then you keep asking, did I write it? Did I write it? Did I write it? Did I write it? Until it says, yes, that byte is now written. Then you go back and try to read again. So that approach will work basically by opening both of those file descriptors as non-block. However, if you use that method, this is also called a busy wait or polling method, which means if you look at the processor load, it will just be at 100% because the process always has something to do. It's always calling read or write to see if there's something to read or to see if I can successfully write one byte to the output. The alternative, which is what we have done in this class since socket 2, is to use the select call. We can use the select call to monitor changes to file descriptors. Do I have a byte ready to be read? Can I write at least one byte to the output file descriptor? And that's basically what we have done so far with socket 2 to socket 4. The select-based solution is very efficient because you can use a single thread to do it. No multiprocessing, no multi-threading. So in terms of resources, it is extremely efficient with resources. However, it requires a bit of work to keep track of the state of each pump. Now with a pump, it is not really bad because you read a byte, you echo the byte to whatever it is supposed to send out to. On the other hand, if you're supposed to do any type of processing, then it gets much more hairy. Okay, because if you're supposed to read a byte or read some bytes in, do some processing, and then output the processed data to the other end, then it gets a lot more complicated because you have to keep track of state information, and the complexity of the state information depends on what you're doing. Okay, just to give you one example, GCC, GCC takes the standard in and it can output it to the standard out, just like CAT can. Okay. But what is the complexity of GCC compared to CAT? In terms of what type of processing you have to do with the input and what kind of stuff you're outputting.
Simple string replace.
Okay, GCC is far more complex than CAT. All CAT does is to concatenate all the input files, all the bytes, string it together, concatenate everything, and send it out. But GCC has to do all kinds of processing. Okay. If we use select, for that sort of application, then it becomes, a lot more complicated. But fortunately, GCC is not a bidirectional pump; it is a monodirectional pump or unidirectional pump. In other words, GCC takes standard in, do the compiling, send it out to standard out, and that's it. Okay, is that making any sense so far? So in that case, GCC obviously does not need select for that purpose because it does not have two ways, does not have the other direction. So the same problem, which is a bidirectional pump, can also be solved by a multi-threaded program. And this is just a snippet out of it. In other words, I left some really crucial parts out. The first thing I do is I define a structure called a pump. And all it does is to have two members. One is in FD,